Okay, so let's see how we're going to actually evaluate logarithms in this video. In order to be able to evaluate logarithms in any base, it does require that we have some kind of either calculator or a software that can do this for us. So the assumption is that we have some kind of a calculator for this lecture, and I'll show you. I'm going to use a Microsoft calculator that comes with my laptop, and I'll show you that in just a moment. Now, in general, we're going to take a look at two very broad type of logarithms. The ones that are called common logarithms. So we're going to talk about that one, common. And we're going to talk about the natural logs. These are the two most common ones. There's also a third one. So we have common, natural, and then we also have log. I know not many people heard about this one. Unless you're a computer scientist, then you definitely know about this one because it's used throughout scientific computer science community and computer science textbooks, log. So let's begin with common log. The reason for common here, the word common in common log, is because before the advent of calculators, the older mathematical textbooks from algebra to higher math, they had a table in the back of the book, which is now antiquated. It's no longer even there. We don't even know about them anymore. Especially the newer generations don't know about it. So these tables that were attached at the end of every textbook, math textbooks, there was a table of logarithms. Because again, calculators were not so prevalent at that time. So the common log references to a logarithm whose base is 10. Okay, and again, extensive tables were developed. So there's this table in the back of the books. Depending on the book, it ranged from anywhere from like 5 to 10 pages, additional pages in the back of every math textbook. Now, thankfully, we don't need those anymore, but the name stays with it. So that's what makes it common. It was common to every math textbook. Now, a log base 10 of x is just like any logarithm whose base is greater than 1. The graph of it is actually going to look something like this. This part, there you go. So that will be the graph of this common logarithm. Make it more like this. It goes through 0.10, the x-intercept is 1, and it's going to be very flat here. Nonetheless, there is a slant, so it goes to infinity, but it will take it a long time to get there. So this is just a graph of the common log. The natural log, that one is called natural because it is used quite often in modeling growth and decay models, and it's also used in life sciences quite often, so hence the name natural log. The natural log is a log whose base is e. Okay, now remember, e, just like pi, is an irrational number whose decimal approximation is 2.718 and so forth. Now the natural log is often written as ln. In fact, that's how we even read it. ln of x is how this is read. Oops, sorry. ln of x. That's what the natural log is. So this is a log base e. If we have a log base e of x, we're simply going to write it as ln of x, natural log of x, just a shorthand for that. The common log, so that we don't have to write the base. And remember the older textbooks, it was very difficult to do typesetting and do these subscripts, superscripts, and mathematical expressions. So they try to simplify it as much as possible. So in the textbooks, the common agreement convention was to leave the base out. So if the base is out, remember it's there, it's just we choose not to write it. So we assume that there is a 10 in there, okay, in that base. For natural log, we leave the base e out by writing ln of x. What does the graph of natural log look like? Again, base is 2.7, call it about 3. So it's going to be like a common log, except it's more like so. There. That's going to be the graph of natural log of x. Again, it has that general rise that all log base a greater than 1 do. Just the degree of how high it rises, how steep the curve is, depending on the base. As the base grows, then it's not as steep. So this would be the graph of ln of x, if you're interested in the graph. Now in calculus and higher courses, we tend to, by the way, work with natural logs more often than common logs. It makes our calculus work out nicer. All right, so we have that one, and then let's take a look at the last one that not many people know about it. It's not much used, and that's log of x. Log, LG, short for log of x. Log of x is simply a log base 2 of x. That's what that is. Okay, and because base is 2, so this also looks like ln of x. Actually, 2 would be even more like this. There you go. And this becomes lg of x, log of x. Now, our most common calculators, by the way, have the natural and the common log on them, but they don't have log and they don't have other bases. In a few minutes, you'll see I'll go through a change of base formula, which now we can handle logs in any bases using our calculators. And one other thing about the natural log I want to mention is because in the previous section, I mentioned the Scottish mathematician John Napier, that was a developer of logarithms. The natural log of x is named in his honor, so oftentimes we call the natural log the Naperian log, again in honor of the Scottish mathematician John Napier. So it's called Naperian logarithm. Just wanted to mention that also. So let's see, before I show some examples, let's go through our change of base formula. So we've covered everything about logs with varying bases. This is the change of base formula. Now to provide the formula for you, let's say I'm going to start with an expression like this. This is like the derivation of the formula. So suppose I have y is equal to log in some valid base a. And remember, we can understand logs only through their exponential form, where they were born out of. And that would be the exponential expression. Equivalent to that, again, if you need a review of logarithms, please watch the previous lecture in section 4.3. So this is x equal a to the y. Now, take the log of both sides. This is an equation, so pretty much we can do anything as long as we do to both sides of an equation. So I'm taking, as we say it, taking the log base b of both sides. And when I do that on the right side, I can use properties of logarithms, bring y in front of a log as a factor and write it as a log a in base b. And then we can solve for y. To solve for y, we divide both sides by the other side is we're going to divide both sides by the coefficient on y, which is log base ab. So I'm going to divide both sides by that. The right side divided by it, of course, it goes away. The left side, you're going to get log x in base b divided by the coefficient on y. And there you have it. This is indeed what the change of base formula looks like. So what the change of base allows us to do is, for instance, let's say I want to do log base 4 of 7, and my calculator cannot handle this base 4. So what I could do is I can actually go to another base. In this case, I'm going to go to a common log or a natural log. Those are the most two common bases, because almost every calculators have them. So there you go. Now we can evaluate these logs. And remember, a log base e is a natural log, so I can do ln of 7 divided by ln of 4. If I chose to, I can also do a common log, couldn't I? Again, as long as my calculator can handle a common log or ln or both, I can do either or. And there you have it. And in a moment, we'll evaluate this just so you see how it's done. But this is what the change of base is. So let me actually bring up and do this example. This is a calculator I'm using. Again, it came with my Microsoft Office, or just in general with the operating system. Notice in here, by the way, I have near the left bottom, I have these powers and 10 to the x, x to the y, x squared, and so on. And down here, the lower left corner, I have log, the log. See that? No base, that's common log. And this is the ln, the natural log. So let me actually do this. First, I want to do ln of 7. So I'm just going to go, let's see, I'm going to go 7 and then hit ln. There you go. Quite a few decimals, huh? Just going to write this number just so you have it for reference. Oops, sorry. So the number is going to be 1.9459. Okay, and then we're going to divide it by ln of 4. I'm going to clear the entry, and I'm going to do 4 and then do ln. That gives me 1.3863. 3863. And of course, if I divide them, I'm going to divide 1.9459 by 1.3863. The answer is going to be 1.40. Let's go 1.4037. And of course, if you know that I rounded the numerator, rounded the denominator, so my answer's got two sources of rounding in it right now. Probably the way you want to do it is this way. Let me do it now the different way, where there's not so much rounding error. What I like to do is to do ln of 7. So that's 7 ln. I'm not going to write this. I'm just going to go ahead and divide it. Divide by 4 ln, right? 4 ln. And you can see the expression up here, by the way. You see that? Ln of 7 divided by ln of 4. And equal. Once you hit equal, you get 1.403677. Before I had 1.40366. It wasn't off too much, but still, you know, for those who want to do this in one pass, you could do that. Now let's use the common log to do this. Okay, so the same problem is going to be, call this L for the log. There you go, that I'm doing. Log 7 base 4. I'm going to do L, which is 1 point, this is my L. Okay, I'm going to do this using common log. So I'm going to go log 7 over log 4. And this time, I'm just going to let the calculator do the whole thing instead of me writing the in-between steps. So that would be, again, logs, common log of 7. I'm going to go 7 common log divided by 4 common log. You see that? Equals. And look at the answer. It's exactly the same as before. That's going to be 1.4037. So it doesn't matter where you go, common log or natural log, whichever your calculator is capable of. Now, let's just do maybe some examples here. In this example, it's not a change of base. Let's say I want to do a log of 0.1. I'm going to do these to 4 decimals. Okay. And let's say we want to do log of 10, and we're gonna do log of e. Now log of e, and then yeah, let's say we want to do that one, and then let's do these other ones where we don't need a calculator necessarily. For natural log, let me do ln of 28, for example, using a calculator, and see if we can work these. And then separately, we're going to do log base 10 of 10. Okay. Let's do log base e of e. And remember, this is just natural log of e, right? And this one is simply common log of 10. These are the same. And how about something like this one? Suppose I want to do ln of e to 1.6. And then separately, let's do ln of 1 over e squared. And I think that's probably good enough. Maybe one more, ln of square root of e, something like that. So let's see how these go. And actually, for most of these, I can do them exact values. I don't need a calculator, but let's start with the first one, a log of 0.1. So whether this is log or natural log, doesn't matter. I have a calculator. The numbers will be different. That matters. It's just, I mean, it doesn't matter in the way I'm going to use my calculator. So I'm going to go log 0.1, and let me clear the entry, 0.1, and then I'm just going to go log. And there you go. The answer is going to be -1. The answer is -1. What does log of 10 look like? So I'm just going to again, clear entry here, and I'm going to do a common log of 10. So I'm going to go 10 and then common log. Oh, 1. And that's not surprise, right? And that's not surprising, because if the base of the log, argument of the log are the same, the answer is going to be 1. And that's in fact what I have in here now, right? Over on this side, right over here. And common log of 10 is 1, because that's just base 10 that I haven't written. Next to this, log base e of e, that's going to be 1, because the base of the log and the argument of the log are the same, right in here. So I can say natural log of e is 1, because that's log base e of e. How am I going to do ln of e to 1.6? Using the power rule of logarithm, that's going to be 1.6 ln of e, but then we just showed ln of e is 1, so the answer is 1.6. Notice I'm using just the properties of logs to do these. Let's do ln of 1 over e squared. ln of 1 over e squared, this one. That I can do it a couple of ways. One way, the easy way, is to rewrite 1 over e squared as 1 over e to -2, then bring -2 in front of a log. That makes it -2 ln of e, but remember, ln of e is 1. So that part is 1. The answer will be 2. Or I could have done it this way, using the quotient rule, write it as ln of 1 over e squared, write it as ln of 1 minus ln of e squared. Natural log of 1 is 0, because log 1 in any base is 0. And then using the power rule of logarithms, bring 2 in front of a log, we get -2 ln of e, and then again ln of e is 1, so I get -2 times 1, which is -2, and there's the answer to this one. With the square root of e, I get ln of e to 1/2. Bring the half in front. That's ln of e, and that's 1 also. That's 1 times a half, because ln of e is 1. We just mentioned that. See how things work out really nicely with natural logs. Now, For what I have up here, log of e, ln of 28, I'm going to go to my calculator. So I'm going to go 28 natural log. That's 3.33, right? 3.33. So I'm going to write. And then round it to 2 decimal. You can go to 4, as many accuracies as you like. 3322 would be to 4 decimal. Usually we go to 4 decimals. Now, gotta be careful here. That's not gonna be 1, right? Only when the base and the argument are the same. What's the base of the one that I have circled? What's the base of this one? Remember, if the base is not written, it is 10, correct? It is gonna be 10. So for this one, I'm just gonna use a calculator, right? So I'm doing common log of e. Let's see if I have that. Yes, good, perfect. See that e here? I'm gonna hit right there. You go. That's e, by the way. I said approximately is 2.718, but again, it's an irrational number, so those digits go forever. 718281828459045, blah blah blah. All right. And we're going to do common log of that, log. And the answer is going to be 0.4343 to 4 decimals. And there we have that one. So you can see how we can evaluate these logarithms again. Some of them we can use properties of logs, and then other ones we simply use calculators where necessary. Okay, and so this is a short video because we didn't really want to do much other than evaluating logarithms. And we did the change of base. Remember, I used the change of base right here. So we did one example of change of base. This example is right in here. All right, and with that, we are done with this video. Thank you for watching. Have a good day or night.